Hello, my name is Ron Papaschmidt, and I'm the creator of the Net Zero Now YouTube channel. And this is going to be a condensed version of Session 1. Session 1 was devoted to why we need to get to net zero greenhouse gas emissions. And so in this shortened version, I'm going to try to condense the information in the longer version to about 10 minutes or so. So let's begin. Here is the first slide we talked about, and we talk about the greenhouse effect, and we have the sun, and this talks about how Earth gets warmed. So sunlight comes down to Earth, and some of that sunlight gets reflected back through the atmosphere into outer space. And that's because it's coming in the form of shortwave radiation, and that sort of does not interact with some of the greenhouse gases. But most of it gets absorbed into the Earth's surface and then gets radiated back as heat, which is a longer wave radiation, and that in turn gets then reflected back to Earth, causing Earth's temperatures to increase. Now, on the next slide here, we'll show the composition of Earth. Atmosphere. So 98% of it is nitrogen, 21% is oxygen, 0.9% is argon, and only 1/10 is really greenhouse gases. So it's a very small amount. If you look over at this chart, you can see the composition of the greenhouse gases. 76% is carbon dioxide, 16% is methane, 6% is nitrous oxide, and the rest make up 2%. So let's move forward here. Now, this graph is really a very interesting and important graph. And what it shows the amount of carbon dioxide particles in the atmosphere. And you can see this graph goes back to about 1880, sort of close to the beginning of the Industrial Revolution. And at that time, we had under 300 parts per million of carbon dioxide in the atmosphere. Now, we're over 400. In fact, the latest number I saw, I think, was about 430. And that's sort of represented by this yellow line here. And then you can see the blue line, which represents temperature. You can see temperature is highly correlated to what's happening with regard to carbon dioxide in the atmosphere. But there's one other factor that's involved, and that has to do with population growth. You know, when I was graduating from high school around 1960, there were about 3 billion people on Earth. And last year, we hit 8 billion people. And we're projected to go to 9.7 billion people by 2050. And if you notice, that curve sort of follows the curve you see here with regard to carbon dioxide particles. So that tells you there's really probably two things going on. One, there are more carbon dioxide particles in the atmosphere, and yes, some of that it does come from the use of fossil fuels and other things. But a lot of that is driven by the fact that we have more people, and that we have not reduced our consumption of carbon dioxide per person as the number of people on Earth have increased. Okay, so it's really both of those factors that come into play. And now you frequently hear people, say the climate's always changing. What's going on right now isn't necessarily anything new and unique. Well, here's a chart that goes 800,000 years. And you can see we have these ice age cycles, they call them, where the level of carbon dioxide goes up and down. Probably goes a little bit under 200 to a little bit under 300 at a top. And if you look at what's happened currently, you can see that the number of carbon dioxide particles have just shot straight up. And that's sort of illustrated by this other chart graph here, which sort of shows what's happened since the start of the Industrial Revolution, how carbon dioxide has gone up dramatically. And so that shows that what's going on right now is not a normal cycle. And in fact, these normal cycles over the last 800 years can be explained by something called the Milankovitch Cycles, which we covered in the more detailed session I'm not going to have time to cover here. So this is really unique and separate, and we need to just recognize that. Now, these charts talk about carbon dioxide. You say, well, there's other greenhouse gases. What about that? Well, that's why I want to show this chart down here real quickly. So we show the chart of temperature. Here's carbon dioxide. Here's methane. Here's nitrous oxide. What do you notice? They all look the same, right? They're all going from the lower left to the upper right. And what that tells us is that really why we're talking about carbon dioxide, it could be any one of these greenhouse gases, or the combination of them. They're really moving in the same direction. So let's get over to the next slide, which is also fairly important. And what I did on this slide, it's a little bit more complex than the other ones, is I went ahead and listed the various different greenhouse gases. What were their major sources? What was the percentage of the gas in the atmosphere? What is the greenhouse warming potential? And then how long does it stay in the atmosphere? So let's start with carbon dioxide. Carbon dioxide, we listed some of the major sources here, like fossil fuels, deforestation, making steel, cement, etc., transportation, etc. It represents 76% of the greenhouse gases, and it has a warming potential of 1. Why 1? Well, they assigned it an arbitrary value of 1 because it was the largest greenhouse gas. And how long does it stay in the atmosphere? Well, it's got different cycles, and some of it cycles out fairly quickly in a matter of weeks and months. But a lot of it, and almost most of it, can last as long as 400,000 years. So we've got to be real careful about the amount of carbon dioxide we put in the atmosphere because it's not going away. Let's go to methane. Where does that come from? It comes from natural gas. It comes from agriculture, particularly farm animals, etc., stuff like that. Landfills, permafrost, other things like that. It represents 16% of the atmosphere, of the greenhouse gases, I should say. But it has a warming potential of 28. So that's significantly higher than carbon dioxide. So we need to be very careful with methane. But there's a good story with methane. Unlike carbon dioxide, it doesn't stay in the atmosphere that long. So if we were able to get our methane emissions down dramatically, the impact of that would move out of the atmosphere fairly quickly in terms of reducing its warming, reducing our overall the overall greenhouse warming potential of greenhouse gases. And nitrous oxide, and that comes from fertilizer, biomass, some industrial processes. It's 6% of the greenhouse gases. It has a warming potential, though, of 265. So we really need to be careful about that. And it also stays in the atmosphere for about 100 years. So let's go next to the next thing that's really important here. It is the level of greenhouse gases, technically the warming potential in the atmosphere that influences global surface temperatures. I'd like to refer to that as the bathtub effect. So we basically historically have greenhouse gases coming into the bathtub, and then we had a drain where they were coming out. And, over the last 800,000 years, generally those things were, over the life cycle of these ice age cycles, it's sort of evened out. That's obviously no longer the case. And so what's happening is the level of greenhouse gases and their warming potential is going up every single year. And so that means 2025 is going to be the best weather we're ever going to have, on average. And next year is going to be worse, and the year after that is going to be worse, because that level keeps on rising. And if you don't think that's significant, think back maybe 10 years ago, and then listen to if you look at the news reports we get right now, every single night on ABC, CBS, NBC, I don't care which major network you look at, their annual news report, half hour, probably about 10, 15, 20% every single day is being devoted to weather events. And it didn't happen 10 years ago. And so if you take a look at that and say, wow, yeah, that's quite a change. Well, the next 10 years is going to be infinitely worse because these levels are going up at ever increasing levels. And therefore, the only way to prevent temperatures from increasing is reduce greenhouse gas emissions to net zero. So let's wrap this up on the final slide here. So how are we going to get to net zero? What happens here? Here's our choice. We have basically two choices. One, we achieve net zero greenhouse gas emissions, and we may have a livable planet, or we continue on our current path, which is going to lead us to just really very, very dire circumstances. The next session I'm going to do is going to be session 2, and it's going to talk about why we need to get to net zero greenhouse gases now. So thank you for listening. Subscribe, give me your comments. Let me know if you like the short versions versus the long versions, and we'll hopefully see you at session 2.